Chapter 7, Section 3, Integration by Parts. Integration by parts is a method of integrating or anti-differentiation when integration by substitution does not work. I'll repeat, we use this method if integration by substitution does not work. Integration by parts comes from the formula for the derivative of a product. The derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. If we integrate both sides of this equation, which would mean integrate each term, we have the integral of the left side would equal the integral of the right side. Write it term by term. So when I say antiderivative instead of derivative, here I'm going to say the antiderivative of the derivative of uv. We'll just say that's uv, the antiderivative of the derivative of uv. And I'm going to copy all the rest of this. The integral of u dv plus the integral of v du. Then we're going to subtract. We subtract this from both sides of the equation that we just wrote. And we get a formula. It's called the integration by parts formula. uv, subtract this thing I circled in yellow, equals the integral of u dv. So we're going to repeat this every time we do a problem. This is called integration by parts right here. So it's worth repeating. The integral of u dv equals uv minus integral v du. Let's do page 350, exercise 4. Integral or antiderivative 2t cosine 3t dt. The 2 that's multiplied in front here is going to go to the left of the integral symbol. And you should think about how this is impossible to do using integration by substitution. Integration by magic chalk just won't work here. Try it and you'll see. So we're going to use the method called integration by parts. We let u equal a part of this. I'm going to pick t. We'll discuss later how to decide. And dv will be everything else that's here, including the dt. dv equals cosine 3t dt. So before we return to the original problem, we do things to both of these equations. For this u equals t, we say if u equals t, then du equals 1 dt. From u equals t, it follows that du equals dt. And from dv equals cosine 3t dt, we're going to integrate both sides of that. The integral of dv is just v. And this integral actually requires integration by substitution. So we go over to the side of this and say let w, since u was already used in this problem, we're going to let w equal 3t. Then the derivative of w, dw, would equal 3 dt, because the derivative of 3t is 3. That means over here, I need a little more room to show this. So the integral of dv, right here, this becomes just v. This integral over here, cosine 3t dt, requires the magical appearance of a 3. It just says dt here. We need it to say 3 dt. And we can make the 3 appear as long as we also put in the 1/3. Magic. V equals 1/3 the integral of cosine w dw. 3t is w right here, and 3 dt is dw. So v equals 1/3 sine w. There really should be a plus c here, but we're going to save writing plus c for the very end of the original problem. Don't write it here, it will just cause confusion. So v equals 1/3 sine 3t, because the derivative of 1/3 sine 3t is cosine 3t. Well, now we actually have to go back to the original problem, which is here. It starts with a 2, then there's an integral symbol. Well, then there's a t, but the t is equal to u. Look over here. Replacing t with u. And then there's cosine 3t dt, all of that equals dv. Cosine 3t dt, every bit of that equals dv. Then, every time you write, or I write, the integral of u dv, every time, it gets followed with this. Every time we write integral u dv, this should be the next thing you write. uv minus integral v du. Every time. So this right here, integral u dv, it's uv minus the integral of v du. This 2 in front is times all of that. The 2 will be distributed. And that's actually what we're going to do right now, is distribute the 2 and turn the u and the v and the du back into what they are from what we wrote down. So distributing the 2, we have 2u. In that spot we're putting t. Next to that is v. Where it says v, we're putting this. 1/3 sine 3t. And then there's this minus. We're going to write another 2, because like I said, the 2 is distributing. Then this integral symbol. Right here where it says v, we're going to write this again. This, whatever we put in place of v, same thing has to go here. 1/3 sine 3t. And then here where it says du, we have to put dt. It's from way up there. Where it says du, we put dt. So this term here, we're going to simplify it a little bit by saying 2 times 1/3, so that's 2/3. Copy that t. Sine 3t, copy that. After this minus, this 1/3 is going to come to the left of the integral sign, but there's already a 2 there, so minus 2/3 the integral of sine 3t dt. And here we actually have to use exactly this again. W equals 3t, which means we wish there was a 3 right here. Here it comes, 3. Abracadabra. Well, don't forget that requires a 1/3 out here. Here's what we got now. 2/3 t sine 3t minus 2/9 integral sine 3. I was going to say 3t, but I want to say sine w dw. 3t we call w, and 3 dt is dw. Copy 2/3 t sine 3t minus 2/9. The integral of sine w dw is negative cosine w. And here's where the plus c comes in, because we're just about done. Just about. Not yet. The integral of sine w dw is negative cosine w plus c. Final answer is 2/3 t sine 3t plus, there's negative times negative, that's plus 2/9 cosine 3t plus c. This w turns back into 3t, and we're actually finally done. That's integration by parts. Fun. Not easy. All right, let's try number 6. It's 350. Integral of x squared e to the negative x dx. So once again, integration by substitution will not work with this. Integration by parts, let u equal a part of this. dv equals everything else. e to the negative x dx. Deciding which part to let u equal is something we'll talk about in class. It could be trial and error in the meantime. And dv has to be everything else. dv has to include dx. That's a rule. dv equals something with the dx, or dt, or whatever variables are. So, don't go over here yet. From u we get du. The derivative of x squared is 2x. Attach a dx to that. From dv equals whatever. We say integrate both sides of that. There. The integral of dv is just v. And this actually requires magic chalk that I'll try to say without writing it all down. If we let u equal this exponent, the derivative would be negative 1 dx, requiring the negative 1 to appear here, which also requires the reciprocal of negative 1. Can't put this negative 1 without that negative 1. So this is now, in my mind, the integral of e to the w dw. I might have said u a second ago, but you should use a different variable here. That's e to the w dw, now with the green there. And the integral of e to the w dw is just e to the w plus c. Don't write plus c there. So from u we get du, from dv we get v. This is being called u. Read over here. All this is being called dv. And every time we write the integral of u dv, the next thing we write is uv minus the integral of v du. Always. In this problem, u is up here, x squared. V is right here. Negative e to the negative x. Copy this minus, copy this integral. V is over here. It's negative e to the negative x. And du is up there. Du is 2x dx. So I'm going to rewrite this a little bit. This is a positive times a negative. So we have negative x squared e to the negative x. Two negatives here, so we'll say plus. This 2 can go to the left of this integral. The x that's way over here, I'm going to put it at the beginning. And copy the e to the negative x and the dx. Now, what you'll love about this problem is we have to do integration by parts again. We call this repeated integration by parts. We're going to let u equal a part of this. So this is a brand new u, not one from up above. U is equal to x. dv is the rest. That means e to the negative x dx. From u equals x, we get du equals dx. From dv equals e to the negative x dx. We just talked about that. From that, we get v equals negative e to the negative x. Plus c. Put back over here. Negative x squared e to the negative x plus 2 integral. This right here, x equals u. This, all this underline, equals dv. Says it over here. So integral u dv. The integral of u dv is always u v minus integral v du. But the catch here is that 2 there means 2 times all of this. And don't forget this term from earlier, negative x squared e to the negative x plus. So we'll now distribute the 2 and also turn the u and everything else back into whatever they are. Negative x squared e to the negative x plus 2. U, the most recent u, is up here, x. V, this is v now, it's negative e to the negative x. So we use parentheses here. And then we have this minus. We'll have another 2, distributing this 2. The integral sign. The v here is the same v that's there, so it's negative e to the negative x. But du is this now, dx. Du is dx, it's from there. So here's what we have. Negative x squared e to the negative x. This multiplication here is a positive times a negative. So it's negative 2x e to the negative x. Here's multiplication with 2 negatives, so that's positive 2 integral e to the negative x dx. As I see 2 negatives here, that's where this positive came from. But this is an integral that we've done twice already. The integral of e to the negative x dx. You insert a negative here and a negative here, that's the integral of e to the w dw. Negative x squared e to the negative x. Negative 2x e to the negative x. The integral of e to the negative x dx is negative e to the negative x. When integration by parts is necessary more than once, like it was here, we had integration by parts right here, integral u dv, and then we got here and had to do it again. That was way down here, the integral u dv, that's the integration by parts again. There's another strategy that's a little more efficient. It's called tabular integration. I will demonstrate that with page 351, number 24. And once you see how this works, I think you should try using this method I'm about to demonstrate. Try using that method on this problem, exercise 6. In tabular integration, integrate something like x to the third cosine 2x dx. This can be done using integration by parts, but it would require a repeated use of integration by parts. So the other method, we make a table with two columns. The heading of one column is f of x and its derivatives. And the heading of the other column is g of x and its integrals, or antiderivatives. I'm going to say integrals. So we have these two functions here, one in purple and the other one underlined in green. One of them is going to start out the f of x column, and whatever we pick for the f of x column, when we repeatedly take its derivatives, we need it to end in a zero. So the derivative of x cubed is 3x squared. The derivative of that is 6x. The derivative of that is 6. And the derivative of 6 is 0. If this didn't go down to a 0, then we put the wrong function in this column. Cosine 2x, if you keep repeating the derivative, taking the derivative, it's never going to end up in 0. But x cubed does. And this method won't work unless one of the functions gets down to a 0 when you keep differentiating. The other function is cosine 2x. We don't need the dx here. We're going to take the integral of this function until we get to the bottom of this table where the other side ended. The integral of cosine 2x is the sine of 2x times a half. I'm mentally doing some magic chalk thing here. Or you could mentally go backward and say this is correct because the derivative of sine 2x is cosine 2x times 2. You can cancel with that 1/2. So the derivative of this in the black is the green. The integral of sine 2x, ignore the half for a minute, is negative cosine 2x times a half because of the magic chalk thing, but there's already a half there. So we now have a 4. The integral of cosine 2x, I'm ignoring the front number in front. The integral of cosine 2x is sine 2x. Times a half. But there's already a negative 1/4 there. I have a negative 1/8 in front now. I have to do this one more time because these have to line up. So ignore this number in front. The integral of sine 2x is negative cosine 2x. I said negative cosine 2x times a half. But there's already a 1/8 there, so we're going to end up with 1/16. And it's going to be positive because there was already a negative there, and the integral of cosine is negative sine. So if you want to double check this, the derivative of this thing on the bottom should be this, what's right above it. The derivative of this should be what's right above it. The derivative of this should be what's right above it. The derivative of this should be the original. These are all supposed to be antiderivatives going down. So you can check those to make sure that they're right. Then we connect the first one in this column with the second one in that. Just draw these arrows like this. So nothing gets connected to this cosine 2x. And the 0 gets connected to nothing. First one here gets connected to the second one here, and so on. These arrows get labels on them. They're going to be signs. The first arrow will always be a plus sign, and then they alternate. So the labels on these arrows are positive, negative, positive, negative. Always start with positive on the first arrow, and then alternate. The answer to this problem here, exercise 24, is going to be positive, see the sign and the arrow, this times this. I'm going to multiply the ones that are connected, minus sign on top of the arrow, this purple times this green, plus, what's the sign here, that times that, and then negative that times that. It looks like this. Positive that times that is going to be 1/2 x cubed sine 2x, and then negative that times that, but that times that is going to be a negative. We negate a negative, that'll be positive 3/4 x squared cosine 2x. And then the next arrow has a positive, so it's positive that times that. That over there is negative, so it's going to be negative 6/8, so then like 3/4 x sine 2x. And then the last arrow has a negative attached or on top of it, so it's negative that times that. That means the last term in this answer it's negative that times that, so it's negative 6/16, we'll call it 3/8 cosine 2x. And don't forget the plus c at the end. Done.